I guess I'm in the middle. There we go. We're supposed to sit underneath our names, which is exciting, assuming I remember my name. And thanks, Redbeard, for the introduction. I usually don't think of myself as a mega expert. I think of myself more as a hacker in the best possible way. Thanks, everyone, for being here. The lights are really quite bright, which is exciting. There really is no more important topic in the world of technology than security. Really isn't. And it's very poignant for New York in this particular location. Just across the street, a few steps from here, the Hilton Hotel in New York City, I just wrote a story last week, was hit by a point-of-sale malware breach. JP Morgan disclosed not that long ago a breach, guys downtown, 80 million people impacted. So it's something that New Yorkers in general and everybody in the United States needs to be aware about. It's not specific to containers. It's not specific to any individual layer of the stack. It's a problem that all of us are impacted by. So what we're going to talk about on this panel really is about automating security and how automated security and containers in particular can help us limit risks and improve our chances of success in this very dangerous world. So we're just going to start with a few introductions. I'll start on my left. And if everyone can just give 2 minutes of what you do and what your view is on container security, and then we'll just jump into some specific questions. So start off, Frank.
Sure. So I'm Frank McCreary. I'm CTO and founder of Aptable. We are a deployment platform that manages risk and compliance for companies that are deployed in the cloud. So we've got a product that uses containers to actually manage the applications, databases, and all services that our customers host in the cloud. And then we've got a set of SaaS tools that ingest event logs from everything that they're doing and mapping it onto whatever regulatory frameworks they need to comply with, be it HIPAA or ISO, PCI, FISMA, et cetera.
Great. Tim?
Hi, I'm Tim Hobbs. I'm part of our product management team at CA Technologies. CA is one of those companies that everybody in this room probably thinks of as a legacy company. We're trying to change that perception by making real action. So we're really changing what we're doing with our perspective towards newer ways of doing things like containers and everything that we're talking about here. So we're trying to just spur that effort, and that's part of my responsibility.
Matt?
Hi, I'm Matthew Garrett. I'm a security developer at CoreOS. The work I've been doing most recently has been on the trusted computing work that was discussed yesterday. And I work on primarily things just below the direct container level integration between platform security and container security.
That's great. And now, because the three of us don't actually work for CoreOS, so we can talk about what CoreOS is doing right or wrong. We'll start with you, Frank. What do you think about the great work that Matt and CoreOS has been doing with distributed trusted computing, and how do you think that will help security in general?
Yeah, sure. So so I'm coming at this from working with companies that have to deal with regulatory compliance. And one of the biggest barrier to cloud adoption is a lack of trust in the cloud and kind of a lack of understanding on the part of many companies that need to comply with various regulations on how to deploy all their applications, which were previously on-premise in the cloud. So the distributed trusted model, it provides a very well designed engineered solution to this problem of trust, where trust is no longer required of whatever cloud infrastructure you're running on. So that's one very important piece. The other important piece is all of the audit logging that it provides. So basically anything that happens in this distributed trusted model, any containers that you deploy from the point that a system is booted up, every event gets logged. And can be reviewed by a security officer and engineering team. And so this is just going to make it easier and easier for companies to move their systems to the cloud.
Fantastic. And Tim, what's your view, and how does that mesh with what CA has been doing historically in other systems?
Right. So we have a lot of experience with the companies that run everything and the governments that are behind it all and in watching all of you. So we know exactly how important the entire trusted stack is. And before this week, that was one of the big concerns is from the hardware on up, how do we know that we're running trusted things? I think the announcement's fantastic. It's really going to do a great amount of, it's really going to help everybody accept that this is a technology that we can use, containers and everything else are a technology we can use for all those things that we thought we couldn't use it for before.
That's fantastic. And then Matt, I know you've been spending a lot of time working on this. As the human, and I know our title of our topic is automating security, if you could just give everyone just a little bit of color as to how that's going to help automate the process of security attestation overall and remove the odd human from the process.
The trusted computing work allows us to bring a much greater degree of, trust, unfortunately, into the stack at a much earlier point in the process. And one of the things that is going to be possible as a result of this is using the hardware to create a secure communication channel before you've actually deployed anything to a system. So that's going to make it practical to deploy secrets to systems without manual intervention during initial provisioning. So we've already got the potential to remove one of the more tedious steps of bringing up a cluster. You're not going to have to manually involve yourself with every system in order to ensure that you can deploy keys to it in a secure way. So that's a significant part of it. But then the attestation, the ability to ensure that a system is in a known state at a given point in time, again, that's something that is going to make it possible to reduce admin overhead, to have making it easier for admins to have confidence in the fact that their systems are in a secure state without having to check so many things by hand.
That's fantastic. And then on that, extending on that topic, Tim, if you could just give me a little bit of color as to what sorts of things you're doing at CA and what sorts of best practices you have for our audience here for further automating security beyond just distributed trusted computing.
Sure. So a big part of our business is, of course, implementing security in all these different levels of compliance and maintenance and overhead and collection of what's going on in your entire environment across the world and bringing it all together to make actionable things. So it's really exciting for us to take all of our expertise that we have in all of those bare metal installations and bring that to this different environment, but new environment, which brings its own challenges, and sifting through all those challenges, deciding who's going to solve what part of it, and if we can bring a lot of our previous expertise to bear, that's the critical part of what we're looking at.
That's fantastic. And then, Frank, from a healthcare perspective at your company, what are you doing to automate security? What processes do you have in place?
Yeah, sure. So I guess just by background, the majority of compliance operations today are still done via Excel spreadsheets and engineers sitting in a room with compliance officers trying to document how they've complied with each regulatory requirement for every single one of their deployed applications. And so the way that we're using containers, broadly speaking, is to encapsulate all of that documentation, all of the integration tests for security processes inside the containers. So, for example, when we build containers on Quay, we automate every security check in the build process. So we have an audit log of that. We're basically trying to eliminate this error-prone and tedious communication between compliance and engineering teams by baking that into the deployment process.
And just going half a step further, because I know you have to deal with HIPAA-compliant information, which is challenging, and then there's privacy issues in there as well. Can you use containers, whether it's whatever the runtime is, whatever the packaging format is, to enable your compliance efforts, or is it just another checkbox, or how does it figure in?
Yeah, so I mean, it solves a lot of the problems that we face. So, I mean, I guess a big difference between HIPAA and, say, PCI or other frameworks is that, so PCI, you can actually be evaluated and get a seal of certification. There's no such seal in HIPAA. You have to self-attest everything, just as you are, say, attesting that your taxes are in order when you file taxes. And so using containers and deploying containers everywhere and deploying them with a system that has audit logging built in solves a very critical piece of the HIPAA compliance problem.
That's fantastic. And then from a CA perspective, how do you see it fitting into a compliance environment, whether it's HIPAA, PCI, or otherwise?
Well, it's interesting because compliance is one one aspect of the problem. And being able to take all of this data that's being generated from the containerized frameworks is very interesting, and we've always focused on the levels above that, which is bringing it all together to say, here's how you can self-attest, or here's how you can ensure that you still are in compliance, because we'll tell you what you need to do because of the things that we've noticed. So the other part of it is, at all the different levels of the code review, of the container inspection, of the system inspection, and then of the overall running application, is security at all those different levels. And that's something that we've really been starting to look at in our research organization, and identifying that the fundamental thing that really brings security through all those levels is the culture of the people putting the systems together. It's not about the code, and it's not about the tools. It's about what your methodology is and what your mentality is for building applications that are fundamentally secure.
Fantastic. And then Matt, from a technical perspective, when I've spoken to people about using containers in a PCI environment, they always talk to me about microsegmentation. Give each network, each container its own specific network slice. When you look at it from a security perspective, is that a good approach? Is that something you can help to enable at the container runtime level, or is that SDN magic afterwards?
I think to a large extent that's going to really be a very individual decision. It's going to be very focused, very much influenced by the requirements of a specific deployment. I think there's not really a one-size-fits-all methodology to the correct approach to networking in the container world. I don't know that there is necessarily something we can do that is going to provide a convincing answer for everybody just out of the box.
Fair enough. And then half a step further, because I've got to ask the controversial question, though I don't have any cat pictures, sorry. Containers, can they run outside of a hypervisor in a secure way? And I know, of course, you will integrate with Clear, and that's a configuration flag, so it's not on by default. But is it possible to run in a properly isolated, just using cgroups, namespaces, et cetera, without a hypervisor?
The issue here is, to some extent, really, again, influenced by how you look at the problem. Containers, when compared to the previous model of generally running multiple services on the same operating system with no segmentation, containers are inherently a security win there. And if containers make it more practical to use your systems with this kind of isolation, if the alternative to containers would be to run your applications all in the same operating environment, then containers are definitely a strong security win. But in terms of the degree of isolation containers offer compared to the degree of isolation that VMs offer, yeah, there's still a difference there. Even though we've seen vulnerabilities in QEMU that would allow attackers to break out of VMs into the host operating system, I think we're still at the point where the security offered by containers is less strong than the security offered by VM-based isolation. And that will change over time. We're going to have more trust in this. This code is going to get to the point where we can place that level of trust in it. We don't typically worry about kernel bugs in the context of allowing one process to look at the memory of another process, even though that's basically equivalent to what would be involved in breaking out of a container and doing damage there. I don't think we're at the point where running untrusted code in a container on the same physical hardware as your mission-critical database is a good idea, but I think that's somewhere where we probably will be within a reasonable time frame.
Fair enough.
But that's a fundamental piece right there, is you don't go run untrusted code on your production servers. You just don't do it. It's bad practice. It's bad hygiene. I mean, that's...
So at CA, when you're talking to your customers on deployment, is the recommended best practice to run inside of hypervisor XYZ, whatever it is?
We don't have a specific recommendation because as far as we're concerned, that's a risk evaluation that each customer will make themselves. And we have customers that take a lot of risk because for their business it's appropriate. And we have a lot of customers that, or governments for example, that take very little risk because they have a very different business.
Makes sense. And then from an applicable perspective, how are you running containers today, in or out of a hypervisor?
Well, we're definitely not using containers as the only element of separation. And so it's really just one piece. Everything is run on top of a hypervisor. So we're isolating containers onto virtual machines and onto networks based upon business rules, regulatory rules. I think that I would say I agree with Matthew that this is that getting to the point where you could run untrusted code in a production environment where you've got production data, that's something that's going to happen in the foreseeable future, but it's not where we are now. And I don't think anyone's presuming that you can do that with containers right now. Containers are, I don't think their benefit is in allowing you to ignore all other security best practices. They just make it easier to isolate your running processes, your services, in a way that you might not have done before, because it's a lot cheaper, a lot more lightweight to containerize a process than to like package it into a VM. So people isolate more and more of their services into containers than they ever did before, where they were deploying multiple services on the same VM before. Now they're separating them into multiple containers.
Good.
From our perspective, there's a lot of ways to control this entire problem with process and with procedure, because most of our customers are coming from their established data center enterprise world. If we're talking about containers running on things that are out in untrusted environments, then I think we're talking about something else, but that has room to evolve.
So far we've talked about systems and infrastructure, but fundamentally these things are all run by users at some point. So let's just shift to talk to users, because whenever I talk or write about security, it's never the machine's fault. It's always the user. The user was breached. Somebody clicked on an email. Somebody did something wrong. Something was misconfigured. Otherwise, so when we talk about automating security, and we'll start with you, Tim. And I know Brandon this morning talked about DEX for user authentication, et cetera, OpenID. How do we automate security inside of a container model so that the user is not a risk to the system or to other users?
Well, that's, we're talking a lot about prevention of things. And if we turn it around and talk about how we take secure things and help them enable what we want. With users, it's really how do we get that user identity into the container in a standard way? And that's the fundamental piece here, is we have the opportunity to reinvent how we bring identity to applications. We've tried that with the web for a long, long time, and it's broken in so many ways. We have the opportunity here to really fundamentally fix that underlying issue of who is coming to my application and how can I reliably trust that identity and find that identity in a standard place.
And then Matt, is DEX the right piece, or is there some other user identity or user protection piece to protect users against the system and then against other users?
From the perspective of trusting people against other users, where you can look at this again in multiple ways. When you're deploying in a container environment, you're still placing some trust in the other containers not being an immediate vector for attack. You don't want there to be a scenario where someone else's mistake in terms of their deployment in your environment is going to compromise the rest of the system.
Sure.
So from that perspective, the technologies we're building around increased isolation of containers are important there. So using SE Linux as an additional mitigation technology is a way of making it less likely that compromise of a single container can be turned into compromise of a greater quantity of your infrastructure. So identity management is a component here in the sense of you want to be very sure that the person that you're authenticating is the correct user for this action. Mm-hmm. But in itself, I don't think that is what's going to provide the bigger difference in the sense that you're talking about.
Fair enough. And I see far too many companies raising money in user behavior analytics, so some kind of overlay might be the right way. But from an apptable perspective, how are you managing that user risk? And usually when I think healthcare, I think zero risk, and you probably have a zero trust policy, I would assume, or hope.
Yeah, sure. So, there's a couple pieces here. So, in terms of users making mistakes, in our case, it's less often the end users that our customers serve, so just consumers out there using healthcare applications, but the users of our services, the users of services like Tectonic, that are managing their secret configuration parameters in not very good ways. And so I think that I think that coming up with better ways of managing configuration secrets on like massively distributed systems is like a very important step, so that companies aren't trying to manage those secrets, distribute them to their systems themselves. So like baking that into the distributed trusted system is a very good step. I would say that I mean, this is not container specific, but the approach that we've taken is to containerize a bunch of common services, so analytics services, logging services, everything where a system might be sending out data to third parties, where you're just massively increasing the surface area for attack, bringing those all in-house, and lowering the bar so that's not only like enterprise companies that are hosting all of those solutions on their own infrastructure, but allowing smaller companies to do the same.
You have multiple user populations as well. I mean, you have the administrators of the system and you have the end users of the system. And right now, in so many of the tools that we're using in this environment, the administrators have full capability to do everything.
Sure.
And being able to bring the same level of risk evaluation and heuristic analysis of behavior to end users, we need to bring that to the administrators and the administrative capabilities.
Absolutely, because 8 out of 10 attacks I personally write about are privilege escalation. So it's the low privilege, then he escalates and gets in, because that root user should not be out on the internet, but most people will just sudo out anyway.
Absolutely.
Because they don't understand Linux privileges, but that's another story. We've got 2 or 3 minutes left. I've got more questions, but wanted to make sure we've got enough opportunity for people in the audience. So if anyone has any questions, Mr. Redbeard will be the runner, I guess. Just raise your hand, let them know. Otherwise, I can always ask other questions. Got one over there?
You mentioned the container running in the hypervisor. So if you want to run the hypervisor in the container, would you have container, hypervisor, container? Like how, if you're using the container to package your application, you don't want to package an entire VM. Do you now run the risk of having many, many layers?
Who's the question to?
Person from Aptable.
So I mean, I'm not certain how you'd run a hypervisor inside the container at this point. I mean, so we're just running all of the way that we're deployed is on top of Amazon EC2. That's how we're getting our virtual machines, and then we're running containers inside of that. We're not experiencing this like deep kind of, I don't know, nesting problem that you're talking about. So I don't know if someone else wants to comment on that.
So Rocket, for instance, supports bringing up containers inside hypervisors, and you can have a mixed system. Rocket will allow you to launch a number of containers in just as containers, and then if you pass the appropriate flags at startup time, you can launch a different set of containers in VMs instead. So you can have a system where you have containers and then you have basically lightweight VMs. So we're not actually bringing up the VM inside a container as such. We're just bringing up the VM directly instead of using a container. But it's the same image, the same container file that is being used as the basis for that.
Good. We got a question on the front.
So just to poll the audience or the members of the panel, I'm curious, in each of your minds, what is the deepest problem that you're seeing right now for container security?
Fundamentally, container security relies on the security of the kernel. The isolation guarantees that, whether the isolation guarantees that it provides are actually the same as the ones that it allegedly provides. What we've seen so far is that there are still weaknesses in that space. It is still excessively frequent to hear stories about a bug that allows you to escape from, say, a mount namespace or a PID namespace. And those are concerning. Those are things that really we need to do something about. And it's good to see that in the past month or so, there's been increased conversation, discussion about improving kernel security, and I think that's going to be a focus over the next couple of years.
I think there's nothing insurmountable that's there. There are problems that are observed and they need to be fixed. But if we're going to look at containers as having the same isolation as VMs, then is that the right question we want to ask? So I think that's the part where we need to evaluate what type of security we expect containers to bring us, and then make that happen or decide that it's not possible, and then find an alternative.
Yeah, and I would just say that the biggest gap right now is that best practices are still developing here. I think that it's if you're like operating a container runtime yourself, it's not entirely clear exactly how you should separate your containers across, separate them in different networks and different virtual machines. And I think that having more guidance on that is something that's going to develop over time.
And just from my perspective, I think that history is the greatest teacher always, and we don't have enough history yet as far as real publicly disclosed attacks against production container infrastructures to tell us anything. I think the retail industry is still learning from this Target hack a year ago, give or take, and figuring that out. And then 2-3 years from now, it'll be manifest, and retail will be stronger than it ever was before. I don't think there has been enough security research, and by security research, I don't mean from the vendor side, I mean from black hat security communities, nation states, et cetera. And I think when we see the first large-scale attack come out, then we will see these other gaps. So that's why you have to have that adversarial kind of approach, because when you're inside the bubble, you don't see everything. So from my perspective, the jury is still out, and it'll probably take a good year to 18 months until we see a major attack on containers, and then we'll see where that comes from.
I actually have one question here for the panel. So, building on the question there, one of the concerns for many people actually arises around how data is consumed and written inside of a container. Today, there are a number of limitations with the storing of attributes on a file system in tracking them to users, which make it problematic to use with mount namespaces. Do you think it's more important at the moment to dedicate that engineering effort to fix more of the permissioning problems on file systems, or do you think it's more important to educate the community on how to use remote, like object storage and things, thus kind of alleviating that and being able to leverage ACLs in a different way?
Two approaches to the problem. I think that we have investigated a lot of things about running everything in memory and bringing your data and your identity to an application to run it and then going away, and your data never goes onto storage. So that problem goes away. At the same time, there are cases where you do have massive amounts of data that you need to deal with, and therefore you need some sort of storage volume. So I think some of those cases are more easily solvable than others.
Wonderful.
Okay, so I'm gonna ask you a possibly incisive question based on your commentary. So there's been lots and lots of concern about container security here, like this is a new thing, but containers are not a new thing. There have been people running containers in production. I mean, just look at Cloud Foundry systems that have been deployed. I think Heroku was container-based. Joyent's been running containers in production a long time. Google's been running containers in production a long time. So I'm not really, and where are the container-based exploits in the field, given that all of this stuff has been deployed? I mean, I've used LXC years and years and years ago, when we were never especially concerned about exploits and that. So what are you guys really talking about here with regards to this?
There's a difference between, it's also, in my line of work, I used to get the same questions about virtualization when VMware came in, and the IBM guys, and some IBM people here, oh, we've been running virtualization on the mainframe for 50 years. There's a difference between containerization, BSD jails, Solaris zones, LXC, and then this whole packaging where we've got the application, the packages, and the runtime. It's the difference between saying, okay, well, we have a mainframe virtualization, whatever. There's much wider usage potential. There's much wider application potential usage. There's more users than just the system users that would have used LXC. It's just a different model. It's my perspective.
Are you talking about Docker security or container security?
All of the above.
But all of this is a means to an end. So if we, yes, it's about the technology and that's interesting, but it's really a tool to allow people to do things more efficiently and effectively. And if it's the right tool, then let's use it. And if it needs to be modified, then let's do that too. That's why we're here. I mean, I don't think we're saying that security problems are insurmountable and it's an issue that stops us from moving forward. What we're saying is that there are concerns about a variety of things which we're all aware of, and all we need to do is motivate ourselves to take care of them.
So I think one way of looking at this is that up until recently, the majority of people who were deploying containers were moving from a model where previously things were just all running on the same systems. And so containerization there both brought increased management ease, but also improved security. But as the technologies improved and become more accessible, people are going to start using containers in ways that they're going to move from, say, using VMs to using containers. And that does result in a change in the security concerns. And I think that's really the next step of the growth of containers.
And then the only other thing I would argue is if you ever look at the OWASP top 10 security list, the top 10 vulnerabilities, it's largely unchanged over about 15 years. So it doesn't matter what the system is. It doesn't matter if we're talking VMware, containers, Windows, or Linux. Cross-site scripting, SQL injection, cross-site request forgery. These are similar vulnerabilities regardless of the deployment mechanism. We just have to keep relearning the same lessons. And there seem to be new generations of developers and operators that keep coming up that have to keep relearning these lessons, which is why I think if we can automate some of the better layers of testing as part of the DevOps process, that will help. But the wonderful thing about security, which gives me job security, is it's the same problems time and again. We just have to keep relearning the lessons. And I think we're out of time.
Yes, we are.
There we go. I see the 0, so we're good to go.
At that point, we will go ahead and transition here. Thank you so much to you fine folks for your time and giving us a lot of insight into this.